A very good morning to all of you. So I welcome you all on YouTube channel of Unacademy's IIT JAM Live. This is Srishti Batra and I teach live on Unacademy's Plus platform in IIT JAM category. So in this particular session we are going to discuss practice questions on electrochemistry. So we'll be starting with some basic questions, then definitely we'll increase the level of our questions. So without further delay, so let's begin with our session. So I welcome you all on this platform. Very good morning to all of you, those who have joined this session. Very good morning, Lavina. Good morning, Lovely. So now let's begin with our session. All right. So this is our first question right there in front of your screen. Please read this question and let me know your answers. Okay. And please use all the concepts that we have studied in the lectures. So it's very important for us to solve the questions in a right direction. So this is the first question in front of your screen. Okay, this is on Faraday's law of electrolysis. You have to tell the correct option for this particular statement. Good morning, Nidhi. Very good morning to all of you. So this is our first question for this session. Yes, what's your answer for this question? So let me read the question. The question is Faraday's law of electrolysis are related to the atomic number of reaction, atomic number of anion, equivalent weight of electrolyte, or speed of the cation. So these are options given for this question. Okay, what about Lovely and Lavina? What's your answer for this question? Good morning, Anuj. Good morning, Priyam. All right, perfect. Okay, the answer for this question is option number C. How it's this is the correct answer. C. If I talk about Faraday's law of electrolysis, okay, so Faraday's law of electrolysis is nothing but W is equals to ZIT. Okay, this is your Faraday's law of electrolysis, where W is your weight of electrolyte that is deposited and Z is your equivalent. Okay, Z is your equivalent over here and I is current in amperes. All right, and this is your time definitely in seconds. Okay, so this is your Faraday's law of electrolysis. So definitely Faraday's law of electrolysis are related to equivalent weight of the electrolyte. Okay, how it's related to equivalent weight of electrolyte? What is your equivalent? Okay, Z is nothing but W by 96500, where this W is nothing but equivalent weight. Okay, or let's write this as equivalent weight. Okay, so this is nothing but your equivalent weight. So definitely it's directly proportional to your equivalent weight. So correct answer for this question is option number C. Okay, yeah, very good all of you. Let's take next question now. And this is our next question. Okay, it's also related to the previous one. Okay, you just need to apply the concepts in this question. The question is electrochemical equivalent for is more for. Okay, this is nothing but more. Okay, you have to tell the highest value. The highest value is for hydrogen, it's for Ag, it's for copper, or it's for Zn. This is the question that you have to tell. Good morning, Mosmi. Good morning, Sambhav. Very good morning, Sonia. Okay, all right. What about others? See, these are all basic questions. Okay, so now we have to actually focus on basics also. Okay, if we are clear with basics, then definitely we can move to advanced topics. Okay, yeah, so correct answer is definitely Ag. How it is correct answer? Electrochemical equivalent. That means we are talking for Z. Okay, we are talking about Z. What is Z? Z is nothing but equivalent weight divided by 96500. And now what is equivalent weight? Equivalent weight is nothing but molecular weight. Okay, molecular weight divided by your N factor or equivalence. Okay, so now for H2, molecular weight is 2, alright. For H2, molecular weight is 2 and N factor is definitely 2, okay. So this equivalent weight for H2 is 1. Okay, equivalent weight for H2 is definitely 1. Okay, now if I talk about Ag, so definitely molecular weight for Ag is approximately 107.9, or we can take 108. Okay, divided by N factor is 1 for Ag. So definitely the correct answer is option number B, 108, because the molecular weight is 63.5 and it's approximately 58 or something. Okay, so yes, the molecular weight is highest for silver, so correct answer should be option number B. Okay, yes. So now let's take next question. All right, I'll use the different ink now. So now I hope yellow is visible, right, Sonia? So let's take next question now. Okay, very good morning, Neeraj. Good morning to everyone. All right, so this is your next question, and the question is the electrode potential of hydrogen electrode in neutral solution and at 298, not and at 298 kelvins. Okay. Okay. All right. Okay, Sonia is going with B, Lavina B, Nidhi B. What about others? Yes, everyone. So, all of you, please tell me this answer. Okay, all right, all right. What about others? Okay, so have you guys read this question right twice or thrice? See, just again, I'm giving you some time. Okay, see, just again read this question. Are you sure that option number B is the correct answer? See, this is how you're going to do silly mistakes in questions. Okay, again read this question. Okay, you just figure out your mistake. See, this is the simplest question one can ask from electrochemistry, okay? And still you are giving me the incorrect answers. Fine. So just again read the question and tell me your mistake, okay? And now just correct your mistake. It's very important. All of you, those who are present in this session and those who are giving me option number B as the correct answer, please again read the question and figure out your mistake. Okay, all of you, those who have told me this option number B as answer, Lavina, Sonia, Nidhi, Lovely, Neeraj, Anuj, Mosmi, Saket, just quickly read the question and tell me the answer. See, this shouldn't be done. Okay, right now we are just 2 or 3 months just before from our exam. Okay, so this question is really very simple. Okay, so just let's do this question. Okay, let's do this question. So what we have to do in this question, the electrode potential. Okay, we need to find out the electrode potential, not standard electrode potential. Okay, you are saying 0, which is nothing but standard electrode potential. Okay, it's 0 for standard hydrogen electrode potential. Okay, but here we are asking electrode potential. Okay, that means E cell. We have to calculate E cell, not E naught cell. Okay, you're getting my point. We have to calculate E cell, not E naught cell. Okay, so now what is E cell? Fine, what is E cell? E cell is nothing but, first of all, we have to write down the reaction. Okay, let's suppose this is nothing but a reduction half cell. Okay, because that's our default thing, we always take reduction half cell. So the reaction for reduction half cell will be H plus electron will give you half H2. This is going to be a reaction for standard hydrogen electrode. Okay, now if this is our reaction, so how we are going to write down the Nernst equation? E cell is equals to E naught cell minus 0.0591 divide, it's given 298 Kelvin, so we can use minus 0.0591 divided by A, which is your N value over here, log, okay, pressure of hydrogen, right? There is no nothing mentioned over here, so we can assume that it's 1 atm, okay? So 1 divided by H plus concentration. All right, so now what is E cell over here? Now E naught cell value is 0, okay, not E cell value, E naught cell value is 0, so minus 0.0591, okay, and this is nothing but log H plus to the power, H plus raised to the power minus 1, okay, so this is minus log H plus, which is nothing but pH, okay, so final equation is now minus 0.0591 into pH, all right, is equals to E cell. So that is how you are going to find out this particular question. Now you just have to substitute the value of pH over here and you'll get the answer of E cell, okay. It's written over here, this one is neutral solution, okay, so that means pH is equals to 7. You just have to substitute 7 value over here. So just calculate this value, everyone. E cell is equals to minus 0.0591 into 7, okay, and what value are you getting from this calculation? Just do this calculation for me so that we can just get the correct answer, okay. So it's minus 0.0591, all right, into 7, okay. The answer is 41, okay. The answer is minus 413, okay. Option number A is the correct answer. Okay, if nothing is given, we always take reduction half cell, because if we take oxidation half cell, we get different answer. Yes, Sambhav, if nothing is given in the question, you always have to consider reduction half cell, okay, because always we are just calculating all these values with respect to standard hydrogen electrode, okay, and we assume that standard hydrogen electrode is nothing but our this anode, okay, it's nothing but a reference electrode, that is anode, okay. So yes, definitely always you have to take reduction half cell, okay. If they are asking for oxidation half cell, then they'll mention it, okay, otherwise you always have to take reduction half cell. It's clear? Is it clear, Sambhav? Just let me know if your doubt is clear, okay, because this one is actually genuine doubt, okay. So yes, always you have to consider it as reduction half cell, okay. Great, let's take next question now. See, this one is very simple question, okay, so I request all of you, please do not hurry up with your answers. Take yours, okay, give yourself time, give question time, read question properly, and then give your answer, okay. Now let's take next question. Make sure you give the questions enough time, okay, then give your answers. All right, so this is our next question, and this is one form of Latimer's diagram given, okay, and these are corresponding E naught potential values. All right, so just have to tell the E naught of Mn6 plus to Mn2 plus in moles, okay, this is your question. So just do this question, right, take enough time and then give your answers, okay. This time you don't have to give me incorrect answers, okay, so take enough time. See, it's a Latimer diagram given Mn6 plus to Mn5 plus, Mn5 plus to 4, 4 to 3, 3 to 2, okay, and these are corresponding E naught cell given. So what you have to find out, standard electrode potential for Mn6 plus to Mn2 plus process, okay, in moles you have to give your answer. Okay, all right. Okay, Sonia is saying 1.66, Samba 1.66, Priyam 1.66. What about others? All right. 1.66. Okay, so most of you are giving me 1.66 answer. So I'm giving you 30 more seconds to solve this question. So you can just solve this question and tell me the correct answers. Okay, all of you, those who are present in this session. All right, so most of you are going with 1.66 only. So let's solve this question, okay? So how we have to solve this question? See, in this particular question, it's nothing but Latimer's diagram, okay? So first of all, what we have to find out, Mn6 plus to Mn2 plus in volts, okay? So now how I can just find out this value? See, I can make pairs, okay? E naught of Mn plus 6 to Mn plus 5, okay, is nothing but 1.28 volts. Okay, then E naught of Mn plus 5 to Mn plus 4 is 2.9 volts. Okay, then E naught for Mn plus 4 to Mn plus 3, okay, is nothing but 0.96 volts. Alright, then you have E naught Mn3 plus to Mn2 plus. This value is nothing but 1.5 volts. Okay, and what you have to find out? You have to find out E naught for Mn6 plus to Mn2 plus. That means you have to start from here and you have to get here. All right, so basically what I can do, if I use that direct method to cancel out the values, so this will be cancelled out, this will be cancelled out, okay, this and this, that means if I expand these equations, so all these species will be cancelled out and I'll be left with only Mn6 plus this 4 electrons, which will give you Mn4 plus. Okay, so this is going to be our final equation. So how I will substitute the values over here? See, this is 1.28, okay, and we don't have to reverse the sign because this is nothing but written in this particular format only. So this is this is 6 to 5. That means there is only one electron change. Okay, so we need to multiply this by 1. So similarly, we have 2.9, we have 0.96, and we have 1.5, and there's only change of one electron. Okay, but in this particular case there is change of 4 electrons. That means Mn6 plus is taking 4 electrons and it is giving us Mn2 plus. Okay, so that means there is a change of 4 electrons. So we have to just add all 4 values and divide it by 4. Okay, this is how we are going to solve this. 1.28 plus 2.9 plus 0.96 plus 1.5, okay, divided by 4. This is going to be our answer. Okay, I hope after doing this calculation you are getting 1.66. Okay, so let me just verify this. Just give me 1 second. Let me just verify the value, then we'll proceed with next question. Yes, the correct answer is definitely 1.66 volt. Okay, yeah, so this is how we have to solve this problem. Okay, very good all of you. Let's take next question now. And this is our next question. Okay, so let me read this question. The question is, according to the Debye-Hückel's limiting law, if the concentration of a dilute aqueous solution of KCl is increased fourfold, that means 4 times, okay, the value of ln gamma. What is gamma? Gamma is nothing but activity coefficient. Okay, it's nothing but molar mean ionic activity coefficient. Okay, so you have to tell the correct relation of increment or decrease if I just increase the concentration of KCl by 4 times. Okay, so this is your next question. Okay, all right. First, we got first answer, that is D. What about others? Yes, everyone, that is enough time for this question. What's your answer now? According to Debye-Hückel limiting law, if the concentration of dilute aqueous solution of KCl is increased fourfold, okay, the value of ln gamma, all right, what is gamma? It's nothing but molar mean ionic activity coefficient. So you have to tell what will happen if I increase the concentration of KCl by 4 times, okay. What's the relation to gamma then? If I increase the concentration to 4 times, okay, all right. What about others? Please let me know your answer for this question. All right. So we have mixed answers for this particular question. Okay. So now let's discuss this question in detail. So basically, what is the question? Okay. What's the question? See, in this particular case, okay, according to the Debye-Hückel limiting law, if the concentration of a dilute aqueous solution of KCl is increased fourfolds, the value of ln gamma. What is gamma? Gamma is nothing but molar mean ionic activity coefficient. Okay. See, what is gamma and how I can represent the equation of gamma? This is nothing but gamma log. Okay, you can write down log gamma plus negative. Okay, that means mean ionic coefficient is equals to minus A. Okay, minus A Z plus Z minus. Okay, this is how we are going to write this case, and then we are going to write down this root of I. Okay, that is log gamma plus minus 1 minus A Z plus Z negative and root I. Okay. See, now what we are actually doing, we are just increasing the concentration of KCl, okay, by 4 times. So if I write down in this particular case, see, what I am doing, I am increasing the concentration of 4 by 4 times, okay. So see, it is not given in the question whether it's a univalent salt or it's a univalent bivalent salt or so on, okay. So what we'll take AB type of salt. It is nothing but univalent salt, okay. Z plus is equals to 1 and Z minus is equals to 1, okay. And we know that ionic strength of univalent salt is nothing but M, okay. We know this thing that ionic strength of univalent salt is equals to M, okay. So that means what we are considering, the ionic strength is equals to M. Now what we are doing, we are increasing the concentration by 4 times. So can I write the new concentration is 4M? Yes, everyone, just tell me in the comment section. Can I write like this? The new concentration is 4M. Just okay. Just tell me if you are clear on this point. Can I write the new concentration is 4M? If all of you are clear with this point, then definitely the question is very easy. Okay. So if I increase the concentration of univalent ion, the new concentration is 4M. Okay. Yes, the new concentration is 4M. So what can I write over here? That means ionic strength is 4M. Okay. New ionic strength is 4M over here. So I'll substitute this new ionic strength right into this particular under root brackets. Okay. So now this is minus A Z positive Z negative under root of 4M. Okay. So now what is under root of 4M? 4M is nothing but 2M. Okay. That means we have a new coefficient here, that is 2. Okay. So that means this one is decreasing. Why this one is decreasing? Because there's a decrease. Okay. There's negative sign over here. That means this value is decreasing. Decreased by a factor of 2. Okay, decreased by a factor of 2. That is your correct answer. Okay, it decreased by a factor of 2. No, it decreased by a factor of 2. okay, because we have root I, okay, and root of 4 is nothing but 2, okay. The new coefficient is 2, not 4, okay. So you have to substitute. See, ionic concentration is related to your ionic strength is related to your concentration. How? What is ionic strength? Ionic strength is nothing but half, okay, summation of MiCi square, okay, MiZi square. This is your ionic strength, okay. So this one is related to your concentration. So if concentration is increasing by 4 times, okay, that means ionic strength is increasing by 2 times, because we have to write down here root I, okay. So now I hope this all of you are clear with this concept, okay. The correct answer is decreased by a factor of 2, okay. See, this question is very easy, okay. Just make sure if you have devoted enough time to a chapter, okay, so you won't do these silly mistakes, okay. Otherwise definitely you'll fetch negative marks, okay. So there is no point of learning so many concepts if you are doing these silly mistakes, okay. So just practice more and more questions and analyze your mistakes, evaluate your points, and then just work on them, okay. So this is how the correct answer is A, that is decreased by a factor of 2. All right, I hope all of you are clear with this question. If any one of you have doubt in this particular question, please do let me know in the comment section, okay. So let's take next question now, and this is your next question. So if you have doubt in the question, please do let me know in the comment section. See, the difference is there, okay. The difference is there. If I just write down the correct, okay, if I just go with the correct notation, so you can write down ln over here, right? That will be more perfect. See, you can write down ln over here, right? See, the relation is same, Rajendra, okay. The relation is same. Ln is also depending on the ionic strength through this relation or log, okay, because it's nothing but 2.303. So we don't have to include that value, okay. So if I go with the correct value, that should be log gamma plus negative minus a z positive z minus by root I, okay. Okay. Yeah, so most of you are giving me correct answers. That is option number A. Okay, so let's discuss this problem now. The question is a solution of sodium sulfate, okay, in water. That means it's nothing but aqueous solution of sodium sulfate, okay. It's aqueous solution of sodium sulfate, all right, is electrolyzed using inert electrodes. The product at the cathode and anode are respectively, okay. So this is your question. See, now what we have to do over here, if I have sodium sulfate, okay, so I have to write down the cathodic reactions and the anodic reaction, okay. So now I have aqueous sodium sulfate. That means what all species will be present in the medium? We'll have Na plus, H plus, sulfate, and OH minus ions. Okay, so now let's write down anode reaction. So if I talk about electrolytic cell, okay, so what is the charge on this anode? Just tell me. The charge on anode is positive, right? Because the one which is connected to a negative terminal is your cathode. Okay, so anode is having a positive charge. That means negative ions will be migrating towards your anode. Okay, that is having a positive charge. So negative ions are sulfate and OH minus ions. Okay, so now we have to consider the migratory aptitude of these two negative ions. Okay, and we know this point that hydroxide is having a better migratory aptitude in comparison with sulfate. Okay, so hydroxide will definitely, okay, it will oxidize because anode is always responsible for oxidation. Okay, so OH minus, what it will do, it will lose half H2, it will liberate half O2 gas plus H2O plus 2 electrons. Okay, so I'll write 2 over here, 2 OH minus plus half O2 plus H2O plus 2 electrons. This is your reaction at anode. Okay, so if I go by the correct notation, so what I'll do, I'll write 2H plus over here and 2H plus over here, right? 2H plus and 2H plus. So final equation is, this is nothing but two molecules of H2O. Here we have one molecule of H2O, so 1 and 1 will be cancelled out, and now you'll be left with H2O. Okay, it will give you half O2 plus 2 electrons plus 2H plus. Okay, and what is this 2H plus and 2 electrons? Can I write this is nothing but H2 gas? Yes guys, can I write this way? This is nothing but H2 gas, 2 electrons plus H plus. Okay, this is nothing but H2 gas, but we can write down in this way. Okay, then what we have to do, we have to write down the reaction for cathode. Okay, we have to write down the reaction for cathode. So cathode is negatively charged. Okay, so positive species will migrate towards cathode. So we have Na positive ion and we have H plus ion. Okay, so migratory aptitude of H plus ion is greater than Na positive ion, so definitely H plus will take electron. Okay, and it will give you half H2 gas. Okay, it will definitely give you half H2 gas. Now what I'll do, I'll write down the final equation. Okay, so I need to cancel this 2H plus and 2H plus, so I'll multiply this by 2, and this will be H2 gas. Okay, so final equation will be H2O. All right, then I have half O2 gas. Okay, then I have H2 gas. All right, then this 2H plus and this 2H plus will be cancelled out, this 2 electrons and these 2 electrons will be cancelled out, and this is going to be your nothing but electrolysis of water. Okay, this we can say this is nothing but electrolysis of water. So at anode we'll get hydrogen gas. Okay, and at cathode we'll get at anode we'll get oxygen gas. Okay, and at cathode we'll get hydrogen gas. Okay, I hope this is clear to all of you. This is nothing but electrolysis of water. Okay, so is this point clear to all of you? The final equation is H2 giving us half O2 plus H2. Okay, see, you can see the equation is also balanced. You have 2H plus, 2H plus, you have 1 oxygen, you have 1 oxygen. Okay, so I hope this is clear to all of you. Fine, this is how we can balance these type of reactions. Okay, let's take next question now, and this is your next question. So let me just brief you up with this question. What you have to tell me, see, the question is you have to find out the KSP for this particular salt. Okay, that is ferric hydroxide. You have to calculate the KSP for ferric hydroxide. Okay, so now if this is the case, so what you have to find out, you have to find out the correct representation of cell. These are given values, okay, of this E0 potential. So you have to tell the correct option which represents this particular cell through which you can find out the value of KSP. Okay, so this will take some time. Okay, 1 minute will be enough for this question. So you just use your concepts. Okay, take enough time and then give your correct answers. Okay. Yeah. See, the hint for this question is you just take the reference of this particular salt, okay, for which you have to find out the KSP. That's your reference, okay. And how you can get that equation? So just, okay, write the equation of KSP and see the possible options in this four options, okay. Then you can find out the E naught potential and you can decide your correct answer, okay. So this is how you should approach this question, all right. This is a small hint from my end. Now let's see how many of you can just use this hint and solve the correct answer. Yes, all E naught values are written with negative sign. Okay, so Fe3 plus to Fe is minus 0.036 volt and E naught for OH minus to this salt. Okay, metal insoluble salt anion half cell is minus 0.786 volts. Okay, both the values are in negative units only. Fine. Okay, Sonia is going with B. What about others? See, let's take 30 more seconds for this question. Okay. Yeah, in options also it's negative, okay. It's in options also all negative, all values are in negatives, okay. See, this is minus 0.750, okay, minus 0.750, minus 0.750 and minus 0.822 volts, all right. Yeah, all values are in negatives. All right, B. What about others? See how we have to approach this question. The approach is very simple, okay. The approach is very simple. Now let's use the given values, okay. See, we have to find out the KSP of FeOH whole thrice, that means ferric hydroxide, okay. So we need to find out the KSP for ferric hydroxide. So what we will do, okay, let's take a fresh slide. Yeah, let's write it over here, okay. So what we need to find out, see, we need to find out, okay. Yeah, so we need to find out this KSP of ferric hydroxide, okay. This is our question. We need to find out KSP of ferric hydroxide, okay. So first of all, what we will do, we will write down the required equation, that is ferric hydroxide, okay. It will give us Fe3 plus ions, all right, plus 3 OH minus ion, okay. Fe3 plus ions plus 3 OH minus ions. This is our reaction of KSP, okay. So we need Fe3 plus ions and OH minus ions in the right hand side, okay. This is how we need to figure out our correct cell, okay. So let's go back to options now, okay. So these are all options given. That means I need to get Fe3 plus ion in LHS side, okay. I need to just get Fe3 plus ion in LHS side. So that means our anodic compartment should be be iron iron 3 plus, that means metal metal ion. Okay, if this is metal metal ion, that means if let's suppose we have iron in our anodic compartment, so reaction will be iron to iron 3 plus plus 3 electrons. Okay, reaction will be iron to iron 3 plus plus 3 electrons. Okay, so definitely this should be our anodic compartment. So now we are clear that this should be our anodic compartment. Okay, now what we need to do, we need to find out cathodic compartment. Okay, let's suppose our cathodic compartment is metal insoluble salt anion half cell. Okay, we are just assuming. So now the metal insoluble salt is FeOH whole thrice. Okay, so definitely it will take electrons at cathode compartment, so FeOH whole thrice, okay, plus 3 electrons. Okay, it will give you iron plus 3 OH minus ions. Okay, so now if I just use both these equations, so 3 electrons will be cancelled out. Okay, now you have iron will be cancelled out. Final equation will be this thing. Okay, final is your this particular equation, and this is our required equation. Okay, we need to just form this equation only. So now we are clear that anodic compartment is metal metal ion half cell, and cathodic compartment is metal insoluble salt anion half cell. Okay, so now we are clear with this thing. So how we can just write down the this cell representation? Okay, we can write the cell representation also. See, the cell representation is anodic compartment is iron to ion. Okay, that means metal to metal ion. Okay, so Fe, we'll write down Fe solid, then Fe3 plus aqueous, definitely. Okay, then our cathodic compartment is metal metal insoluble salt anion half cell. Okay, so now we'll write down salt bridge. It is not given in the question, so let's just write down this bar. Okay, so you have OH minus ions, which is your ion, so definitely you'll write down aqueous over here. Then you will write down FeOH3. Okay, this is your solid. Then you will write down iron over here. Okay, this is also solid. So this is how our this is how our cell representation will look like. Okay, so yeah, this is our correct cell representation. Okay, now let's get back to options. Okay, so that means we have iron 3 plus, we can cancel out this option, we can cancel out this option. Okay, now we are left with option number B and option number D. Okay, iron 3 plus, iron 3 plus, OH minus ions, and FeOH whole thrice Fe. So this is also given in this particular option. Okay, so now we have to decide between two options. Okay, so for that we need correct E naught value. Okay, for that we need correct E naught value. So let's now find out the E naught value. So our anodic compartment is iron 3 plus. Okay, so that means oxidation is happening over here. This one is reduction potential. Okay, so this is minus 0.036. So how we will find out the E cell? It is nothing but we'll take the negative of it. Okay, that means 0.036 volts. Okay, for iron to iron 3 plus, and then we have metal insoluble salt anion. Okay, and this is given in this reduction form only. Okay, so now we have to just use this value, minus 0.786 volts. Okay, we have to use this value, minus 0.786 volts. Okay, now if we just find out the value, the answer is definitely minus 0.750 volts. Okay, just verify this value, definitely you'll be getting minus 0.750 volts. Okay, so correct answer is option number B. Okay, I hope all of you are clear with this option, this question and the explanation. Okay, if you have any doubt still, right left, so that definitely you can ask me in the comment section. Okay, so this is how we have to approach this question. See, everything is very simple and clear. Okay, see, it's all in our mind. Okay, we just make the question complicated. If we go step by step, so we can solve each and every question. Okay, so let's take next question now. This is your next question. If you have any doubts in the previous one, so please do let me know in the comment section. Okay, so this is your next question. The question is, a certain current liberated 0.50 grams of hydrogen in 2 hours. Okay, how many grams of copper can be liberated by the same current flowing for the same time in a copper sulfate solution? Okay, and you have been given with the atomic mass of copper also, that is 63.5. all right, yeah, so now you have to do this question. Yes, guys, what's the answer for this question? You need to find out how many grams of copper can be liberated at the same current flowing for the same time in a copper sulfate solution. This is based on Faraday's second law. So you have to calculate using Faraday's second law. Okay. All right. 15.875, 15.9, 15.9. Very good morning, Subhashri. All right. What about others? All right, so guys, we have to just use Faraday's second law of electrolysis. Okay, so how we'll just solve this question? See, a certain current liberated 0.50 grams of hydrogen. Okay, in 2 hours, how many grams of copper can be liberated by the same current flowing for the same time in a copper sulfate solution? Okay, so can I write Q is equals to IT? Yes, everyone. Is this formula clear to all of you? Q is equals to IT, okay? If Q is equals to IT, where Q is your charge, okay? Q is your charge and I is your current, okay? And T is your time. If Q is equals to IT, Q is equals to charge, I current and T time. So definitely this I value, okay? And T value is same for copper also and it's same for hydrogen also, okay? So what we can say that charge, okay? Charge through this particular hydrogen is equals to charge of copper, okay? Charge of hydrogen and charge of copper, okay? So that means charge of hydrogen is definitely is equals to charge of copper. So what we can say, that means we have same charges, okay? So we have same units of electricity, okay? We have same units of electricity, or we can say we have same Faradays, okay? We have same Faradays. So I use this relation like this, okay? See, number of equivalents, okay? What we can say, number of equivalents of H2 is equals to number of equivalents of copper, okay? This concept, okay, can be derived from this QH2 and QC2, that number of equivalents of H2 deposited is equals to number of equivalents of copper deposited, or number of equivalents of H2 liberated is equals to number of equivalents of copper deposited, okay? So this is the relation. So now I can just equate the number of equivalents or number of equivalents, okay? Equivalents, that means we are relating Z over here, okay? We are relating Z over here. So what is Z? Z is Z of H2. Just give me 1 second, guys, okay? Just give me 1 second. Just give me 1 second. I need to just plug in my charger. Just give me 1 second. Yeah, so the question is, what we have to find out? We have to find out number of equivalents of H2 is equals to number of equivalents of copper, okay? So now what is equivalence? Equivalence of H2 is equals to equivalence of copper, okay? So now what is equivalence? Equivalence is nothing but equivalent weight divided by 96500 is equals to equivalent weight divided by 96500, okay? This is divided by 96500. All right, so now what we have to do over here, see, this 96500 cancels out each other, and now you're left with equivalent weight of H2 and equivalent weight of this copper, okay? So what is equivalent weight of H2? Equivalent weight of H2 is 2, Okay, equivalent weight of H2 is given weight by your equivalent weight. Okay, what is equivalent of weight of H2? That is 1. Okay, and given weight of your copper divided by equivalent weight of copper, which is nothing but 63.5 divided by 2. Okay, and this is nothing but 2 divided by 2, which is 1. Okay, now this weight is equals to 0.50. Okay, this weight is equals to 0.50, and we need to find out this particular weight. Okay, just tell me the correct value of this weight is 0.50, and this one is 63.5 divided by 2. Yes guys, just tell me the correct answer for this relation. Okay, so is this point clear to all of you, Bhupendra? What is not clear to you, you can just tell me. I'll explain that in Hindi. Okay, so whatever part is not clear to you, you just tell me. I'll explain that in Hindi. Okay, yeah. So is this explanation clear to all of you, those who are present in this session? Just tell me, is this explanation clear? Okay, great. So correct answer is 15.875. Okay, and that is how we are going to do this particular question. Okay, let's take next question, and this is your next question. Okay. 63.5. Why we did 63.5 by 2? Okay, why we did 63.5 by 2? See, what is your equivalent weight? Okay, what is equivalent weight, Nidhi? Equivalent weight is nothing but molecular weight or atomic weight divided by n factor. Okay, and what is your molecular weight or atomic weight for copper? That is 63.5. Okay, and copper valency is +2. That means copper +2 will take 2 electrons and it will form copper. So here n factor is 2. Okay, so now we have 63.5 divided by 2. Okay, so that means this is your equivalent weight of copper. Are you clear with this thing? Are you clear with this thing? Okay, yeah. So what's your timing for classes in YouTube? See, Srishti, I used to take classes at 10 a.m. Okay, on this Tuesdays, all right, Fridays and Sundays. Okay, so the schedule is going to change for the next month. Okay, that I'll update on my Telegram channel. Okay, you can find the link of Telegram channel in the description box. It's already written over there, right? So you can just join in that Telegram channel. You'll be updated with upcoming YouTube sessions even in time. Okay, so you can just join according to those notifications. All right, you can join the Telegram channel, for which the link is already given in the description box. Okay, great. So all of you just solve this question. Let's do this question now. Or what you can do, you can just search Unacademy. Okay, you can just search Unacademy underscore SBATRA. Okay, this is my Telegram channel. Okay, just search this on Telegram web and you will find the link of my Telegram channel. Okay, you will subscribe that. Okay, all right. See, what about others? See, 17 of you are online, and only 2 or 3 are giving me the answers. Okay, what about others? If you are preparing for 2021, definitely you should answer the questions. Okay, this is the only way you are testing your preparation. Okay, and you have to time and again test your preparation. So if you are lacking somewhere, you have to work on that. Okay. Okay, so others are solving this question. So I would like to tell you about this revision course. Okay, that is actually ongoing on Unacademy platform. So this is the ongoing revision course. In this particular revision course, we will be discussing, or we are discussing, all topics for our IIT JAM 2021 exam. Okay, so if you want to ace your exam, so you can also join this revision course. Okay, we will discuss each and every topic of inorganic, physical, and organic chemistry. Okay, so a new revision course is also starting from November. All right, you can just find out the description of this particular course and what all chapters we will be covering. Just go to Unacademy app, search IIT JAM over there, and you'll find out all upcoming batches for IIT JAM chemistry. Okay, so if you want to join this revision course, you can take Unacademy subscription. Okay, we have various plans for Unacademy subscription. We have a month plan, 3 months plan. Okay, and we have month plan, 3 months plan, then we have 6 months plan. Okay, 12 months plan, then we have 24 months plan. Okay, so these are various plans, and if you want to know about the subscription plans, definitely you can message me on Unacademy. Okay, just go to my profile, you'll find the link of my profile in the description box. You can go over there, you can drop your queries over there, right? I'll definitely help you with all your queries, or you can just definitely join this Telegram channel also, and there also you can write your queries. Okay, I'll definitely answer all your queries over there. Fine. So these are some subscription plans for your revision courses. So these revision courses are going to be very beneficial for your upcoming IIT JAM 2021 examination. Okay, so now let's solve this question. So 1 mole of N2H4 loses 10 moles of electron. Okay, the question is 1 mole of N2H4. 1 mole of N2H4 loses 10 moles of electrons. Okay, to form a new compound Y, assuming that all the nitrogens appears in the new compound, what is the oxidation state of nitrogen in Y? See the statement of the question. Okay, it's very simple, and actually they are giving you all required hints. Okay, assuming that all nitrogen appears in the new compound, that means you have to relate this number of mole concept with nitrogen. Okay, so if you have 2 nitrogens in product side, so you have 2 nitrogens in this reactant side. Okay, so that means if one N2H4 loses 10 electrons, so what I can say that one N nitrogen, okay, if 2 N2 loses 10 electrons, so I can say 1 nitrogen loses, okay, how many electrons? 5 electrons. Now why I'm only talking for nitrogen, why not hydrogen? See, let's calculate oxidation state of nitrogen. Okay, what is N2H4? This is N2H4. Okay, you have N2H4 like this. Okay, this is nothing but N2H4. Okay, so if I calculate the oxidation state of nitrogen, which is more electronegative, nitrogen or hydrogen? Definitely nitrogen is more electronegative. Okay, so you're going to write down plus minus 1 over here for this bond. Okay, minus 1 over here for this bond. Okay, and this one is, nitrogen and nitrogen, but still we can say, yeah, so this is 0 for here and 0 for here. Okay, so the oxidation state for nitrogen is -2, or we can also find with this way, 2x minus 4 is equals to 0. So x is equals to -2. Okay, so oxidation state of nitrogen is -2 and hydrogen's oxidation state is +1. Okay, so hydrogen oxidation state is +1. Hydrogen is already present in +1 oxidation state, so it's not possible for hydrogen to undergo oxidation process. Okay, it cannot lose electrons, as simple as that. Okay, so nitrogen is going to lose electrons. Now if N2H4 loses 10 electrons, that means 1 nitrogen loses 5 electrons. Okay, so the oxidation state of nitrogen is -2 if it loses 5 electrons. So now what's going to be a new oxidation state? -2 plus 5. Okay, so that means oxidation state will be +3. Okay, so it has -2, it will go to 0, -2 to 0, -2 oxidation 0 oxidation state. Then from 0 it will lose 3 more electrons, that is +3 oxidation state. Okay, so correct answer over here is option number C, +3 oxidation state. I hope this point is clear to all of you. See the level of question, it's actually very simple. Okay, just you need to read the statements very carefully, and you have to just approach the question with the new statement. Okay, see all hints are actually given in the question. Okay, so that is going to be also in your IIT JAM examination. Okay, you'll definitely have hints in the question, just you need to figure that hint. Okay, and that will only come if your state of mind is good. If you're calm in exam, time. If you're not, just hurry up with your questions. If you're not if you're not confused with the questions, then definitely you can approach each and every question in a right direction. Okay, let's take the next question now, and this is your next question. The specific conductance of AgCl in water was determined to be this at this temperature. The molar conductances at infinite dilution of Ag plus ion and Cl minus ion are this and this Simon centimeter square mole inverse respectively. What is the solubility of AgCl in water? This is the question that you have to solve. And you have to report the solubility of AgCl in molarities. Okay, capital M. You have to report the solubility of AgCl in molarities. Alright, 1.2 into 10 to the power minus 5 molars, 1.2 10 to the power minus 5 molars. Alright, what about others? Only 2 or 3 of you are giving me answers. What about others? There are 13 students live. Okay, so just give your correct answers. 1.2 into 10 to the power minus 5 molars. Alright, okay, fine. So I'm giving you 10 more seconds to just write down your answers. Okay, see, what we have to do in this question, we need to find out the solubility of water in AgCl. Okay, that's the question. So if I have this relation, right, we have molar conductivity or molar conductance is equals to conductivity into 1000, okay, divided by molarity of AgCl. Alright, this is the relation when we have to use this relation. We have to use this relation when this is in centimeters. Okay, and in question it's already in centimeters. That means we need to use 1000 over here. Alright, first thing. Second is this is used when there is no infinite dilution. Okay, now we have infinite dilution. Now if we have infinite dilution, that means we need to use this relation molar conductivity at infinite dilution is equals to kappa or conductivity or specific conductance into 1000 divided by solubility of AgCl. Okay, this is how we have to use this particular equation. Okay, this is how we have to use this particular equation. So now what we need to find out over here, see, this is already given. Okay, these two values are given, so we can find out this value. Okay, and this is already given. So let's find out this infinite molar conductance at infinite dilution of AgCl. Okay, so how we can find out this value? Okay, what is the basic for this chapter? See, if you need to prepare conductance and electrochemistry from very basics or from absolute basics, okay, you just first read NCRTs. Okay, see, NCRTs is actually very good for all these physical chapters. Okay, so you need to start reading NCRTs if you want to prepare from absolute basics. Okay, so just read electrochemistry from NCRTs. Okay, do NCRTs question, the questions which is written inside the box. Okay, and the back questions also after each chapter. Just do all these questions. Okay, once you are just done with all these questions, okay, then you can just start reading for IIT JAM level. Okay, and there's only 30 to 40% extra in IIT JAM. Okay, so first you complete this portion, then you start reading for IIT JAM. Okay, so I have covered all these chapters in detail in Plus platform. If you want to join Plus platform, you can definitely take subscription. Okay, this is my referral code, you can definitely use that. But if you want to just read it from NCRT, so that's the better option. Okay, just start reading from NCRT, then only you can understand the concepts of JAM. Okay, so it's very important for us to just first understand basics, then higher advanced chemistry. Okay, great. So let's solve this question. Now we have lambda molar of AgCl. So how we can solve this question? Lambda molar of Ag plus, okay, plus lambda molar of Cl minus ions. Okay, this is the equation. So we need to just add these two values. Okay, 67.9 plus 82.1. Okay, this is your values for this particular AgCl. Okay, so now let's add these two values. So this is nothing but 67.9 plus 82.1. This is nothing but 150. Okay, value is 150 Simon centimeter square mole inverse. Okay, this is your lambda molar of AgCl. Now what you have to do, you just have to substitute the values. Substitute this value over here. Okay, kappa is already given, this one. Okay, you need to substitute this value over here, and you can find out the correct value of this S. Okay, that is your solubility. So let's do that. This is nothing but 1.8 into 10 to the power minus 6 into 1000. Okay, divided by, all right, divided by, what's your this lambda m coming, this is divided by 150. This is 150. Okay, so yes, you are getting correct answer, that is 1.2 into 10 to the power minus 5. Okay, and this is your solubility value. Okay, the value, the units are actually, what's the unit? See, this one is Simon centimeter square mole inverse. Okay, and this unit is Simon centimeter inverse. Okay, and this unit is Simon centimeter square mole inverse. Okay, see guys, you are getting Simon centimeter inverse for this is the unit of conductivity, and the unit for this molar conductivity is Simon centimeter square mole inverse. Okay, and this part is your constant, so this and this cancels out. Okay, now your unit is mole. Okay, this one is minus 3. Okay, that means mole per centimeter square. Okay, your unit is mole per centimeter square. That means what I can write, your unit is mole per ml. Okay, because 1 centimeter square is nothing but 1 ml. Okay, so this is mole per ml. Okay, and what we need to find out, we need to find out in molarities, that is mole per liters. Okay, and what is liter? Liters is nothing but 1 decimeter cube. Okay, so now what we need to do, see, we need to just divide this by ml. Okay, and we need to just write down this, we need to convert this ml to decimeters. Okay, how we can just convert this ml to decimeters? See, mcdm. Okay, mcdm, this is your decimeters and this is your centimeters. Okay, so 1 decimeter is equals to 10 centimeters. Okay, 1 decimeter is equals to 10 centimeters. That means 1 centimeter is equals to 10 to the power minus 1 decimeters. Okay, so this is nothing but mole by liter. Okay, mole per ml, or what we can write down, mole per this centimeter cube. That means this is nothing but mole per 10 to the power minus 3 decimeters cube. And what is decimeter cube? Decimeter cube is nothing but liters. Okay, so your answer will be 1.8 into 10 to the power minus 5. Okay, that's your answer coming from here. You have to divide this by 10 to the power minus 3. Okay, you have to divide this by 10 to the power minus 3, then you have this decimeter cube, okay, which is nothing but liters. Okay, so your final answer will be 1.2 into 10 to the power minus 5 plus 3. Okay, minus 5 plus 3, and your answer will be 1.2 into 10 to the power minus of this value. Okay, is this point clear to all of you? Any doubts over here? Any doubts to anyone? Just tell me if you have any doubts over here. This is how you have to convert the values. Okay, so you have to convert millimeter, you have to convert centimeters to decimeters, because decimeter cube is nothing but your liter. Okay, so you have to finally report your answer in mole per liters. Okay, that is your molarity. I hope this is clear to all of you. Any doubts over here? Sonia, Rohit, okay, Viswaranjan, Surekha, Sambhav, Priyam, Rajendra, Mrithwin, everyone. Okay, lovely. Nidhi, Chetan, those who are present in this session, then actively responding to the questions. Is this point clear to all of you? Any doubts over here? So this is, yeah, this is 1.5 into 10 to the power minus 2. Okay, this is going to be your correct answer. Okay, I hope this one is clear. See, unit conversions are very important. Okay, so it will be not given in the question that you have to report answer in molarities, but still you have to, this thing should be clear to your mind. What is solubility? Solubility is a unit of concentration. Okay, and what is SI units or general units or acceptable units of concentration? That is mole per liters. Okay, so that is nothing but molarities. So this thing you have to use your mind. Okay, you have to just use your concept that yes, we need to convert this to molarities. Okay, but definitely if they want to make question easy, they'll provide this hint. Okay, but if they are not providing this hint, you have to find this value in molarities only. Okay, great. Let's take next question, and this is your next question. Yes, you just recheck the calculation. Okay, Nidhi? The solution is same. Okay, the steps are same. You need to proceed with this step only. Just recheck the calculation. Okay, after this class, just again do this question, recheck the calculations. Okay, if you're getting 10 to the power minus 2, then yeah, it's the correct answer. Okay. The units are same. Okay, the units will be mole per liter only, or mole per decimeter cube. Okay, see, this question is very easy, right? It's a statement question, so please just quickly give your answers. Okay. Okay, all right. See, the question is very simple. Okay, what we need to do, we need to find out the position of some metals in the electrochemical series in the decreasing electropositive character. Electropositive character. Okay, that means electropositive character means they have given this Mg to Mg2 plus 2 electrons. Okay, so this is nothing but your oxidation potential values. Okay, this is order of your oxidation potentials. Okay, what will happen if a copper spoon is used to stir a solution of aluminium nitrate. Okay, if you're stirring a solution of aluminium nitrate using a copper spoon, so what will happen to that copper spoon? Okay, that you need to find out. See, in the first option it's given copper spoon will get coated with aluminium. In second option, an alloy of copper and aluminium is formed. In third option, the solution becomes blue. In fourth option, the chemical change will take place. Okay, no chemical change will take place. So let's start solving this question. Okay, so if you have what you have a solution of copper aluminium nitrate. Okay, let's suppose this is your beaker, all right, and in this particular beaker you have a solution of aluminium nitrate. Okay, that means aluminium nitrate. Okay, you have a solution of aluminium nitrate. So that means if you have a solution of aluminium nitrate, so you'll have 8 Al3 plus ions. Okay, and you will have nitrate ions. Okay, these two ions you will be having over here. Fine. Then you are just stirring this solution with help of copper spoon. Okay, see, let's suppose this is your copper spoon. Okay, copper spoon means it's present as a metal, copper. Okay, so now what will happen to copper spoon? See, if copper, okay, see this, if copper, if oxidation potential, okay, if oxidation potential of copper is greater than oxidation potential of aluminium, then only a chemical reaction can take place. Okay, and if I just write down, if I just see in this particular order, this is aluminium, that means oxidation state, oxidation potential of aluminium is greater than that of copper. Okay, so nothing will happen to copper spoon. Okay, no change will happen, no change will be there to copper spoon. Why? Because this is the oxidation potential, and that is aluminium will lose 3 electrons first to that of copper. Okay, so definitely if copper is present over here as a spoon and you have aluminium nitrate solution, so there will be no reaction. Now if I want to prove this relation, okay, if I want to prove this relation, how we can prove this relation? See, let's suppose according to this particular given order, it is written that these are the order of your this oxidation potential. Okay, so what I'll say, that oxidation potential of aluminium to aluminium 3 plus, okay, is equals to x volt. Let's suppose, okay, this is x volts or x1 volts. Okay, or E0 potential of copper to copper 2 plus is your x2 volts. Okay, and according to this particular order, it is given that oxidation potential of aluminium is greater than that of copper. That means x1 value is definitely greater than x2 value. Okay, this is clear from this particular question. Now this is our cell. Okay, this is our cell where we have copper and aluminium 3 plus. Okay, so definitely what will happen, aluminium 3 plus will take 3 electrons and it will form this aluminium, and copper will lose 2 electrons. Okay, according to this relation, copper will lose 2 electrons because you have metal of copper and solution of aluminium. Okay, so if this is the case, okay, if this is the case and x1 is greater than x2, okay, so if I write down the reduction potential of these values, this is oxidation potential, okay, and these are reduction potential. So reduction potential will be minus x1, okay, and reduction potential for this will be minus x2. Okay, so if this one is greater than this one, then if I talk about reduction potential, then definitely reduction potential value of x2 is greater than reduction potential value of x1. Okay, simple concepts. Okay, we don't have any values over here, so that's why we are using these variables x1 and x2. Okay, so if this is the case, okay, if this is the case, so this value is positive, okay, and this value is less positive, right? This value is less positive, so there will be no reaction. Okay, there will be no reaction in this particular case. So correct answer is option number D. Okay, correct answer is option number D. I hope this point is clear to all of you. Any doubts over here, just let me know. Okay, let's take the last question for this session. Okay, this is your last question. Okay, so you have 1 minute for this question. The question is, a current of 3.7 amperes is passed for 6 hours between nickel electrodes in 0.50. It's, I think, yeah, it's in 0.50 liters of 0.2 molar solution of nickel nitrate. Okay, you need to find out the molarity of nickel 2 positive at the end of electrolysis. This is your question. So 1 minute is actually enough for this question. Okay, so just tell me your correct answer for this question. Yes, guys, what's your answer for this question? This question is pretty simple, okay? Okay, all right. Sonia is saying 1 molars. What about others? Okay, anyone who can just name this process? Just tell me which type of process we are doing over here, which type of chemical process. We have discussed these processes in class, okay? Yeah, so anyone who can just tell me what this process is called? Okay, 1 molars, 1.2 molars. What about others? Okay, see, what we are doing in this case, okay, the question is simple. A current of 3.7 amperes is passed for 6 hours between nickel electrodes. Between nickel electrodes, that means anode is nickel and cathode is also nickel, right? That is what this statement is saying. A current of 3.7 amperes is passed for 6 hours between nickel electrodes in 0.50 liters of 2 ml 2 molar solution of nickel nitrate. Okay, yeah, so this is the case. You have nickel electrodes at anode and nickel electrodes at cathode, and this is your electrolysis process. Okay, so that means we have solution of nickel nitrate only. When we have solution of nickel nitrate, that means the same ion from your electrodes. Okay, so can I say, guys, that this one is nothing but electrorefining process? Yes or no? You're converting impure nickel to pure one, yes or no? Just tell me. Okay, you have same electrodes, that means this process is known as electrorefining. Okay, you are converting nickel impure to nickel pure, yes or no? Okay, do you agree with this statement? Yes or no? This process is known as electrorefining. Okay, you're converting nickel impure to pure nickel. Okay, yes, everyone, very good, Mritwin, right? So this is the right answer. Okay, if you're converting impure nickel to pure nickel, that means you have 2 molars of nickel nitrate. Let's suppose anode reaction is, okay, nickel to nickel, 2 positive plus electrons. Okay, and cathode reaction is nickel 2 positive plus 2 electrons gives you nickel. Okay, that means you are converting impure nickel to pure nickel. Okay, so that means if this nickel, okay, the anode nickel is actually producing, okay, I have told you, okay, I have also written in this class when we were discussing this process, that if I have 5 moles of copper, okay, impure copper, 5 grams of impure copper, then it will give you 5 grams of pure copper. Okay, if I have 5 grams of impure copper, then it will give you 5 grams of pure copper. That means if this nickel is producing, let's suppose 2 molars of nickel 2 plus ions, so this 2 molars will be consumed, right? This 2 molars will consume 2 electrons and it will form you pure nickel. Okay, that means if the molarity of solution is 2 molars, so answer will be 2 molars only. Fine, the molarity of nickel 2 plus at the end of electrolysis is 2 molars. Okay, I hope all of you got this point. So these were the questions that we have to discuss, okay, in this session. Okay, now with this we have completed all things of electrochemistry. Just two analytical titrations have left. Okay, one is potentiometric and conductometric titrations. Along with these two titrations, we will be discussing acid base titrations, potentiometric titrations and complexometric titrations in our upcoming plus course. Okay, so I'll share this PDF with written solutions in the Telegram channel. You can subscribe to this Telegram channel using link present in the description box. Okay, and if you want to be part of plus courses, all these revision course which is on Unacademy's plus platform, you can definitely take the subscription using referral code SBATRA. And this is a new upcoming special class coming on Unacademy platform. This is a free class. Okay, you don't have to pay a single penny for this class. Okay, this one is free. In this particular class, we are going to discuss micro nodes for chemical equilibrium, ionic equilibrium and phase equilibrium along with practice questions. Okay, so I'll see you in the next class. Okay, till then, take care, keep revising your notes and stay blessed.